Hi, my name is John Anderson. I'm the Maurice Ewing Professor of Oceanography at Rice University in the Department of Earth Sciences. I've been at Rice for 37 years. During that time, I've done most of my research in Antarctica, and that research has taken me to Antarctica, I think, about 25 times altogether. It's actually pretty well known that Antarctica was a relatively warm climate 60, 70 million years ago. Well, the objective of the cruise was to sample older strata beneath the Antarctic seafloor that would tell us something about the history of the continent, its climate history, and when it became glaciated, the last vestiges of plant and animal life when they disappeared from the continent. It was always obvious to us that Mother Nature, the ice sheets, had done a lot of work, that the ice had eroded the continental shelf and removed a lot of sediments, so that older strata were exposed near the seafloor, very close to where we could sample those strata using shallow drilling devices. The fossils that we sampled in shallow drill are all microscopic, and the most important ones were the fossil pollen that comes from the vegetation that used to live on the continent. Well, we found that, for example, about 35 million years ago, the continent was actually covered with a fairly diverse and plush forest with ground cover, and that included flowering plants, angiosperms, large trees, a wide range of trees. And then over a period of about 20 million years, we could see a more or less progressive decline in the diversity of the vegetation to a point where it became basically dominated by one fossil plant, which is called Nothofagus, or tundra. It's typical of the tundra today in places like Patagonia. Well, one of the important things about climate change is we need to put it into perspective. Many people say, well, the climate's always changed, and so what's the big deal about the recent change? And I think the ability to look back very far in time and to understand how climate changed naturally and the rates at which it changed naturally helps us put the current climate change into context. In the past 10,000 years, the climate has changed, but it never changed as rapidly as it's changing today in historical time.